Here we have another problem to explain whether these reactions are product favor or reactant favor. And for that, we're going to be analyzing the reactivity of the species in terms of electrophilicity of the acyl carbon and also the nature of the leaving group in both cases. All right, so here we have, this is 1, 2, 3 propanoic anhydride. So because this comes like from propanoic acid, so propanoic anhydride, and this is sodium phenolate. And let's do this plus negative. This is going to be my nucleophile. And what this is doing is then nucleophilic attack over to, again, the mechanism for acyl substitution under basic conditions. So nucleophilic attack here. And as you do the nucleophilic attack, you will do that, of course. So I'm drawing the pairs of electrons. So I'm going to do this and that. I'm going to form a tetrahedral intermediate, and then after I do the tetrahedral intermediate, the leaving group will be here the carboxylate, and this is just the counter ions. So that's my leaving group. And here I have formed the actually an ester. So we see now what is more stable in that term. So here we know that about reactivity, again, carboxylic acid and derivatives, that most reactants add the acid chlorides followed by anhydrous, because nature of the leaving group is a major thing here. So these are good leaving group, not as great as chloride, for example, but they are very good. So in terms of that, highly reactive, not as reactive, this is an ester, so this is likely to go that way. Now let's analyze that. So very reactive means less stable. This is less reactive, so more stable. We're going that way. Now let's analyze the other two molecules here. This is a carboxylate that is the conjugate base of a carboxylic acid, whose pKa's are around 5. Let's round it up. And this is the conjugate base of phenol. And phenol pKa is 10. So in terms of acid base, whenever we look at this reaction, we say that weaker the acid, we go always towards the weaker acid. But here, let's talk about what species is more stable. When we did this two, this is more reactive, meaning less stable compared to that. Now let's look at this too. This coming from a stronger acid is a weaker base. So weaker base, and here we say this is more stable than that. Even though both molecules, we can see that they are resonance stabilized. When you have the carboxylate, you can do this. And the charge will be delocalized between two oxygens. Here you can do resonance, but charge is going to be, the other resonance structure is going to be on carbon. So not the contribution is not as great as that. So in terms of that, this is more stable than this. So considering this two, this is more stable, less reactive. Considering this two, this is more stable. So we're going always down the hill towards the more stable species. So we're going in this direction. So it is product favor. Now let's do the analysis on the other reaction. We know that these are the most reactive of all the carboxylic acid derivatives. So very reactive and stable. These are the amides, the least reactive. So I'm going to write it out. See, this is the least reactive, and that also means more stable. And acid chlorides are the most reactive in the series of carboxylic acid and derivatives. So many most reactive, so the least stable. So in that regard, we're going to go to more stable species. So we're going this way. And now looking at the other two molecules. By the way, this reaction, when the leaving group will be chloride, as you do that, and so this reaction is typically carried out with excess of amine. so that we neutralize the HCl that is being formed, so that in excess of that. But now let's look at the bases that are formed here. This is chloride. I'm analyzing chloride. Chloride is, which is my leaving group, that conjugate base of hydrochloric acid. And I know here pKa is -7. Looking at that, this is the amines, say. pKa's of amines are close to the pKa's of the of ammonia. The pKa of ammonia is 38. So this will be in about 36. So, and in that sense, well, that's not going to help me much. But anyways, I'm comparing two pKa's, but here I have this acid is very strong. This is stable, so I'm going to go to stable to least stable. So now I'm going again in this reaction. Most reactive is the least stable. Least reactive, more stable. I'm going that way. So this reaction is product favored.